So nice to see you and nice to be here. And to be honest, fantastic they moved NDC Security to March instead of January. I love Oslo, but I love Oslo more in early spring than midwinter. Sorry. So I'm Anders, I'm from Stockholm, and I run a small consultancy business called Sustainsis, and we do, well, when I explain to my kids what I do, I say that I build login buttons. So I do a lot of work with the Identity Server. I have a SAML 2 open source component that's widely used, at least in Sweden. Norway took a more sensible decision and mostly use OpenID Connect. But today I'm going to talk a bit about security features in ASP.NET Core and use OWASP Top 10 as a backdrop or comparison to see for the modern threats that we have in the new OWASP Top 10, how does ASP.NET Core stand up to those? How does ASP.NET Core address those? What is addressed out of the box that we don't have to care about, and what things are not addressed that we have to care about ourselves? So first I have a look at the OWASP Top 10 2025 list, and as everyone knows, when you present a list, you need to go from the bottom. Have a cliffhanger. So number 10 is mishandling of exceptional conditions. Number 9, security in logging and or alerting failures. Number 8, software or data integrity. Number 7, authentication failures. As someone working with login buttons, I'm very happy to see that authentication problems is all the way down to number 7, which means that people are mostly getting that right. Insecure design, it's an interesting thing. So when I've done incarnations of this talk for over 10 years. And when I first created this talk and delivered it, the OWASP Top 10 list was very technical. It was things like SQL injection, it was things like cross-site scripting, very specific things. Now there are more kind of a bit broader categories. Insecure design is more of overall design activity. But it's still an interesting thing to have on here. I'm also happy to see that in the 2025 edition, injection has dropped to number 5. It was injection, and specifically SQL injection, was number 1 for far too many years. It's finally pushed down to number 5. Number 4, cryptographic failures. Using crypto wrong. I mean, how hard can it be? 3, software supply chain failures. That is coming more and more. Number 2, security misconfiguration. And number 1, broken access control. How many of you were in this room for Michelle's talk before this one? Yeah, good. Then you had the basics of access control in ASP.NET Core. I'm sorry, some of the things will be very much a repetition. Great minds think alike, you know. But first look at what broken access control is. If we, for example, have an e-commerce site where we have a list of orders, the order list is of course filtered to only show orders that I'm allowed to access. And then I check one of the links. I can see that it's an order number in the link. What if I would change that order number and try to use a different order number? That is where authorization becomes important. What if the order number was a GUID? Would it be fine then to just rely on the GUID to be security? No, I don't think so. The identifier alone should never be the protection. In ASP.NET Core, we have an extensive authorization system, so I can just touch upon the basic features of it. The base is the authorized attribute. If we work with controllers, Razor Pages or Web API controllers, we have an authorized attribute. Role-based access control was a huge thing when it was presented as something that would solve all the problems. It doesn't. Role-based security is still important and solves a lot of problems, but not all of them. So in ASP.NET Core, we have policies where we tie an endpoint to a policy just by name, and then we have a separate place in the code where we define our policies. So this does the same, saying that you need to be admin, but we now centralize the knowledge of the admin role and the definition of that into one place. The policy system in ASP.NET Core is an extensible framework that is also fairly opinionated. If you follow the guidelines, I think this is an example from the official documentation. You need to be over 18 to access the alcoholic beverages page on the web shop. And that can be translated to have a requirement. A requirement is just a small data, a small class holding information, and then you have a handler that actually does the evaluation. A stupid example. Let's look at another one where you might have more requirements than handlers. So to read medical records or read journal, at least on the Swedish legislation, you need, one of the requirements is that you have to have a smart card login or a strong authentication. And we can have a handler that checks the login method before we allow access to medical records. Another requirement is that as a medical professional, you're only allowed to read medical records if you have a relation somehow to the patient. You can't just go and read anyone's medical records. You need to have a reason. We could implement that with a handler that checks our calendar. Wouldn't that be clever? That if you have an upcoming appointment or you had an appointment in the past, in recent past with the patient, then of course you have a reason to access the records. But we also have another situation. Not all medical situations are scheduled. We might be delivered by ambulance to the emergency room, and then we can have another handler that opens up for that. And there's a vote, and the votes are binding. So if one of these handlers vote no, it's a no. But a handler can also abstain from voting and saying that I can't make a decision. And as long as another handler votes yes, it's a yes. This is a powerful model, but it's also opinionated. I tend to not start here. I start with more simple policies with built-in requirements. I rarely build my own handlers until I need them. One reason to build your own handler is if you want to, a handler is a service in the DI, which means it can also inject other services. There might be cases where you want to reach out to a database, API, or some other service to check something as part of your authorization policy evaluation. But then, as I said, role-based access control was said to be the great thing that solved everything. But it turns out that no, in the end, in the end, it doesn't solve anything. What about a web shop? We have order 42. How do we make an authorization decision? What are the business rules you think for accessing an order? Probably if you are a customer service, you can access any order if you're staff. Role-based security works. But then as a customer, you should be able to access your own order as well, right? And to know who the order belongs to, we need to first load the order. And this was a problem with the old days where you only had attributes-based authorization, because then we had to check the order. You couldn't load the order before you made the authorization decision. Now we can call the authorization service from code, and we can include the order when we send it to the policy. So we can say that, does this user fulfill the policy show order for this specific resource-based authorization? And then we make a decision. If it succeeded, we show the page, otherwise forbid. The policy itself is defined as show order, where we require assertion. Require assertion is my favorite requirement, because it allows me to write an expression returning true or false. I don't have to write handlers to write custom code. I can just use require assertion. In this case, the assertion checks if the user is in role employee, or if the owner of the resource matches the subject identifier of the current user. So we've implemented that customer service or anyone employed at the company can see any order and customers can see their own orders. But there's more to it. The problem with this is that you need to remember to apply authorize attributes and attach authorization policies to your endpoints. And you need to set them right. There is something called a global option, the default policy, which by default means you need to be authenticated. So if you just say authorize without any policy name, the default policy applies. And if you didn't even add an authorized attribute at all, you can set a fallback policy, or the fallback policy applies. So we can say that if the developers forget, I mean, do we ever forget anything? No. But if we would forget, not one of you, of course, one of your colleagues back home, if they would ever forget anything, it might be a safeguard to have a default fallback policy that does something in case there was no authorization policy defined. I prefer this one. Require search and false. What this does is to make sure that the entire system is completely locked down. If we forget to define authorization rules, it's a no-go. No one is allowed to access anywhere, because this will force everyone to remember to add authorized attributes. And you can't just add a sloppy authorized attribute without a policy name, because that will also be denied. You need to have a specific one. We can, for example, if we map static assets, we now need to allow anonymous access. Or static assets, JavaScript assets, nothing will be served. And if we actually want any logged in user to have access, we can have a policy called authenticated. So this is a way that if you want to be secure by default and make sure that colleague of yours that forget to add authorization, that they get stuck, this is a way to handle it. Another example of that falls into this category as well, broken access control. I mean, one of the things I've seen with OWASP 2025 edition is that they wanted to include so much, so things that previously were different categories are now merged into one. That's why I'm also spending half of the talk on topic number one, because this is where the most interesting things are. One of the things is open redirects. It's also a form of broken access control that we don't validate the URL correctly. ASP.NET Core and the login system has a built-in feature that if you have a login page that you redirect to, it captures the URL you try to access to allow to redirect back. Once you have logged in successfully, it allows you to redirect back to the page you try to access. That's great. That return URL parameter, what if I try to enter NDC Security.com on it? Would it work? No, because out of the box, it only accepts local URLs. The built-in redirect that is in the handler. We can also check, we have an excellent help, a URL is a local URL. And we have a specific local redirect we can use when we return a redirect result that enforces it to be a local URL. Is it a good idea to try to check yourself if a URL is local? No. URLs are terribly hard to parse correctly. So it's one of those things where it's great to have a hardened component in the system. Another thing that is also included in broken access control is cross-site request forgery. So let me tell you a story. This story is by now 20 years old. I had one of these modems. Anyone recognize them? ADSL 2 megabit downstream, 0.5 megabit upstream. State of the art. It's fairly impressive that they managed to get internet running at those speeds on old copper wire that was designed for telephones 50 years earlier. So that's impressive, and it worked. One of the things that this modem had was an admin page where you can go in and set DNS settings, because this modem acted as DHCP and DNS server for the local network. So any computer on the network used the modem as the DNS server, and then the modem had to know about what remote DNS server to use. So you could enter configuration, hit save, and it hit some server-side action and it saved it. So one day, I was reading an internet forum, and a security researcher, Leif Nixon, a great Swedish security researcher, he posted a question: do I know anyone who has this specific brand and model of modem? And I said, yeah, I have one. 10 seconds later, I had a PM. Great, can you click this link, please? And that's when I started to think, is this really a good idea? But I mean, Leif he's a great security researcher, and I trust him. So I clicked the link, and I literally got a page of kittens, cute kittens. And I thought that this can't be true. I mean, he can't go all the way to ask for someone with a specific brand and model of a ADSL modem just to show me a page of nice kittens. These must be evil kittens. So I checked the source of the page, and yes, there was a hidden iframe in there that contained a form mimicking the form from the modem and posting it to the address of the modem, changing the DNS settings of my home network. And the idea the problem they had, or assumption the modem had here, was that it was safe to expose the admin UI to the internal network. I mean, the evil kittens are on the internet. But what they are doing is forcing my computer that was on my home network to do the post on behalf of the evil kittens. And also, remember, this was in the day before HTTPS was used everywhere, which meant that it was dead simple to set up a copy of most sites using plain HTTP. And if you control DNS, well, you don't need a phishing mail to trick me to click a link to a fraudulent site. I could go to the actual correct web address, and the DNS that he now controlled would redirect me to a different IP number where I would serve the wrong page. This was my first experience with cross-site request forgery. And the problem here is that the modem failed to validate that it's actually this form that was posted and not some similar form from somewhere else. To protect against this, the usual way to do it is to create a token with a random component. It is also of benefit to tie it to the current user, and then you can encrypt and sign it to make sure the token has integrity. Then the token is stored in the form field. So when the browser loads the form from the modem, it includes this token and also stores the token in a cookie. And on posting, the server can now validate that the token in from the form field matches the token in the cookie. And this is a valid protection because CSRF, or cross-site request forgery, is a blind attack. With cross-site request forgery, the evil kittens can post data to my modem, but there's no way for them to read data out from the modem. They can't load a form, and they can definitely not get hold of the random value that I got in the cookie in my computer. And to implement this in ASP.NET Core, for Razor pages, you are done, because it's enabled by default. For MVC, you can add validate anti-forgery token, and it's also possible for MVC to add anti-forgery tokens to all endpoints. And this will automatically, it will create a cookie for you, it will create the hidden form field thanks to tag helper, it will validate it on post. So, well protected out of the box. Also, ASP.NET Core adds the additional layer that it ties the anti-forgery token to the current user. So if you have two tabs open and you try to save something, and in the meantime you logged in as another user in another tab, you are blocked to prevent saving things to the wrong account. Also, I should mention for cross-site request forgery that the same site attributes for cookies and same site limitation helps a lot, but not all the way. We still should use anti-forgery tokens. Okay, that was number one. Number two, security misconfiguration. Any questions, by the way, on the access control? Huh? Great. So, security misconfiguration. Security misconfiguration is one part of it is that you don't have security features that you should enable. ASP.NET Core does one thing right. It enables use hypertext strict transport security, saying that if your site is served over HTTPS, the browser will in the future reject going to the site with anything but HTTPS. That's good. Also, a typical thing that has been an attack vector in the past is that you try to download PHP files or script files or something that they are in the web root directory, and you can download script files, config files, things that were not meant to be downloaded. ASP.NET Core by default does not serve anything from your application directory. First, you have to enable it explicitly, and by default it serves a subdirectory root. And it's the same with any other feature. There is nothing enabled out of the box. Everything is you need to add to your pipeline and register. And this helps a lot with security misconfiguration. Then there are things that the support could be better. For example, content security policy headers. Andrew Socks and his Net Escapades brand has an excellent library for handling content security policy CSP headers. So this is an add-on. Let's move to number three, supply chain failures. This is where things have happened a lot over the last few years. Supply chain failures has been more prominent as an attack vector, but also there's better tooling. So Visual Studio now puts up a large warning. This solution contains packages with vulnerabilities, and on build it also warns if you have packages with vulnerabilities. Here I just installed an old version of my Sustainable SAML 2 library, and yeah, I had security issues. So that old version is deprecated because security vulnerabilities. And NuGet helps to some extent, because NuGet, they also do basic vulnerability testing, etc., for packages that are uploaded, but not enough. A friend of mine, Martin Baliev, who does a lot of fun things, he went ahead and tried, can I use source generators? If I could put malicious code in a source generator in a NuGet package, will it be detected? No, it wasn't. He could publish the package. He also did another thing. He submitted a pull request to update a package to .NET 10, including updated in Entity Framework packages. This looks legit, right? Just a version update? Actually, this is one of the cases where AI was useful. Copilot reviewed the pull request and said, the package name contains homoglyph characters, non-SQL lookalikes. Microsoft Entity Framework Core should be Microsoft Entity Framework Core. I have no idea which letter he changed, but he managed to publish a package on NuGet that was not with, I think it's the I, that's not the right I. So still, even though NuGet exists, be careful out there. And this is for the .NET side. Then you have the entire client side. Sub-resource integrity, content security policy helps, but you still need to do it. I would also like to take a few moments to talk about this picture. Because I'm maintaining a SAML 2 library, downloaded some 20 million times, used obviously by quite a lot of organizations out there. And it's an open source package, it's free to use. The origin of this is that I worked on a project where we had need for it. That was over 10 years ago. I don't work on that project anymore. I still maintain the package. I do sell commercial support and commercial consulting. I'm also very clear that the commercial support package for my library is a two-way support. As a user of the library, you will get dedicated priority support if you run into issues. and you will get features if you need them, etc. But it's also the other way around. That support package goes to supporting the ongoing maintenance of the library. And unfortunately, the number of organizations willing to sign up for support or support their open source packages they use, it's far too low. So if I can say, and we can see that there was a story with, it was a Linux package, a crypto primitive used by SSH, where there was open source maintainer burnout. And this guy, John Tian, I think the alias was, joined the team, started to send pull requests, high quality pull requests. He was promoted to be a maintainer of the package. He merged, and later it was found out that he had then merged, when he got the merge right, a backdoor. And it was extremely close that that backdoor made it all the way into OpenSSH and all major Linux distributions. But someone found it. So remember, open source maintainers, they're all often small teams doing it on part-time. And I think it's a vulnerability in itself in the model. And so I think vetting your dependencies and see, can we trust this? Can we trust it is going onwards? And how can we make sure that the business critical component we use is also available in the future? So, end of open source maintainer rant. Let's go on to cryptographic failures. Cryptographic failures is about the problem that it's hard to do cryptography right. Even if you have a perfectly correct algorithm, perfectly correct tools, you must know how to use them correctly. And you must know how to pick the right algorithm for the job. ASP.NET helps some in one aspect. ASP.NET Identity Core uses a correct algorithm to store passwords. PBKDF2 with a reasonable amount of rounds. It's one of the approved algorithms to store passwords. Scrypt, Bcrypt, Argon 2 are the other ones that are commonly used. So if you use ASP.NET Identity Core, they solve the crypto part for you. But then sometimes you need to encrypt things that are, you not only need to store passwords, you need to actually encrypt things. So you might use AES. AES is a perfectly valid encryption standard. It's strong, it's correct, it's used everywhere. And to use it, you call AES.create, and then you need to assign a key and initialization vector to it. So key, where do you get the crypto key? How do you create it? How do you store the crypto key? Do you remember to rotate your crypto keys on a regular basis? There's a lot of things you need to do to the key. And even worse, what's an initialization vector? It says it must be a random thing in the documentation. So we just use the string random as a const in our code, right? Well, it turns out it's a bad idea. Initialization vector is a very important part of the strength of AES. Because if you have if you encrypt the same crypto text twice, you will get the same result. And there are also some, if you know the same crypto text, there are also ways to, to recover the key in the end, which is bad. So to prevent of that, AES says that the first block in every data you encrypt with AES should be a random string that is unique for each time you encrypt it, the initialization vector. And now you need to create a random IV. You need to store it with the encrypted payload afterwards. So it's a perfectly valid algorithm, but you need to know a few things and do a few extra housekeeping tasks to use AES directly. ASP.NET Core helps. They have a concept of data protector. Data protector is crypto API as you want it. You can take a source piece of data, protect it, and you get some gibberish. And that thing is encrypted. It has a random IV. The IV is in there, and it is also has a signature, so it is an authenticated encryption. And you can then unprotect it, called Hello World. The API looks like this. You inject the data protection provider, and from the provider you create a data protector. The actual protect call is just protect one part. You can insert a string, you will get binary data back. And then you can take the binary data and unprotect it, and you get the string back. Dead simple, right? And it works well, but behind the scenes, ASP.NET Core does all the heavy work of creating keys, storing keys, rotating keys, and it makes an educated, clever guess of where to store those keys. That works fine on local development. It usually works fine in test environments. It works fine the first month in production, and then someone makes a change to production and the keys are lost. So at some point with the Duende Ident Server support, 30% of all the support issues were caused by data protection configuration issues. So whenever you have an ASP.NET Core application, it's always a good idea to just manually set the data protection configuration, so you know where your keys are stored. But if we look at the vulnerability, I think that ASP.NET Core really helps for the cryptographic usage, thanks to this API, because it's simple to use. You don't need to know the details of how to use the crypto algorithm correctly. But we have the purpose here. What is that? Well, one of the things that the data protection is used for is to bake session cookies. The recipe for an ASP.NET Core session cookie is that you take some JSON that describes the user, you run it through data protection, and here you have your cookie value. Another way where I could maybe use data protection is that, imagine if I have a wizard where I have next buttons, and on one of the steps I do expensive validation of the data, and then I just need to keep it around for the future steps. I could just put that validated data in a hidden form field throughout the rest of the wizard, but then any one of you having browser dev tools could change the data post-validation. So I use data protection. I store the validated data in data protection. Now we have a case for possibility for crypto swap. There is no way for you to bake a cookie because you don't have the crypto key, right? But what if you can control the data that goes into the wizard? What if you enter information in there that is run through the crypto, and then you grab the encrypted data, crypto text swap, and swap it with the cookie? Then you could try to enter information in the wizard that makes you an admin in the cookie. And here's where the purpose matters, because the purpose is part of the key derivation function and ensures that if I try to reuse encrypted text that was used for the wizard, it's not possible to try to use that as a cookie. So the only thing you need to know when using ASP.NET Core data protection is that you need to have a unique purpose each time you use it, if you use it in different places in your algorithm, in your application. So, number 5, injection. This used to be number 1. It's largely solved, but still number 5. It also contains a bunch of different things, and not just SQL injection anymore. The most basic thing is actually array indexing. If you have color codes and we have something that tries to show color ID number 3, it's 0 base, so 3 is out of bounds, right? .NET is a memory-safe language, so if we do this and try to access color codes 3, we will have an exception. We will not have corrupt memory. We will not be able to read memory outside the array. Problem solved. SQL injection then. So if we have an e-commerce site where we can display an order, we have order number 17, and we might have a naive way to build a SQL query. We just use string interpolation. The way this works is that whatever goes into the query string here is then put into the template here and results in a SQL command that can then be run with the database, and that's fine. You wouldn't do anything nasty if you had the chance here, would you? Who would do this? So if we do this, well, whatever goes here is put in here and results in 2 commands. Drop table orders. I guess the e-commerce site might have some health issues after this. So considering that this has not been largely solved, ASP.NET Core obviously should have protection mechanisms to this, right? Well, there's nothing you need to do. Because in ASP.NET Core, we typically use language integrated query, which is type safe. We rarely, very rarely generate SQL ourselves. And if you go all the way to generate SQL yourself, I hope anyone doing so knows about parameterized queries. Another kind of injection is cross-site scripting. So imagine we have a rating for products on our e-commerce site. And someone leaves a 3-star comment. I mean, this is suspicious already here. Nobody leaves a 3-star rating, ever. Have you seen one? I mean, either you're upset with something and you leave a 1 and go on a long rant how bad the company is, or you're happy and you leave a 5 because you're nice. So already here is suspicious. It's even more suspicious that someone bothered to write works but nothing fancy. But what they also did was they included a script tag in the review. Their hope is that when this review is displayed on the site, in the future the script will be run when other people visit and read the review. The mitigation for this is to always remember to HTML escape content before you render it. What if we forget that in Razor? If we just render a string like this right out, well, it will be displayed like this. It will say, because it is HTML escape by default. If you've ever tried to do HTML building tag helpers or something where you build HTML yourself, you have an HTML string and you want that to be not escaped, you have to add APIs and add things to tell Razor that this is HTML, I know what I'm doing, please output it. So once more, secure by default. That's 5 items. Let's look at insecure design number 6. This is not really ASP.NET Core. This is insecure design is more about having bad ideas. Using security questions as a recovery mechanism is a bad idea. It doesn't matter if you make a good implementation of it, it's still a bad thing, because it was a bad idea. The recommendation here is to read specs and follow specs where someone has done the hard thinking. When they created SAML2 spec, they had an idea of IDP-initiated single sign-on, which is called unsolicited responses, is the technical way to implement it, and they describe that an identity provider may initiate this profile by delivering an unsolicited response message to a service provider. And then, reading the spec, the latest version, there is an errata saying that, note that the use of unsolicited responses can lead to cross-site request forgery vulnerabilities. So this is an example where they found out that the idea they had in the spec was bad, but they at least listed in the spec now. So IDP-initiated single sign-on using SAML2 is always vulnerable to cross-site request forgery. You can't implement this spec in a way that is not vulnerable to cross-site request forgery. So what to do? Use OpenID Connect instead. OpenID Connect, I mean, these specs have been written by smart people, groups of smart people that have spent extensive time talking to each other, trying to figure out all the things. If you look at one of these internet specs, you will find a long list of security considerations. And reading these security considerations, to me, it is like the TV show Jeopardy, where Every time I see a validation rule, if you read the rules on how you should validate an ID token, it's like having an answer to a potential threat. Everything you need to do is to mitigate a specific threat. So, secure design, my take on that is use standard things. It's not a specific ASP.NET Core thing. Let's continue with my favorite, authentication. Authentication failures, well, we can have username, password. If we do username, password, we post this to the server. The server validates the username, password, and then our web browser makes a new request, and HTTP is stateless, so the web server is like, hey, who are you? How did you find me? So what do we typically do to make the server happy to remember us? We give it a cookie, right? We give it, when we have validated the username and password or the login method, we give it a cookie, and the server is now happy and allows us to go in. You could implement this. I've been interested in this for long. So very early, I wouldn't say in my career, but before my career, in my teens, when I was toying around with this, I might have written this piece of code. This is a very naive, non-production worthy login method. Can anyone find an error? No, you can't find it, okay. We can have a separate talk afterwards. Too much. So actually, when I created this, I created this way back as a small example, and my idea was to add 3 errors. So far, I think people at conferences have found 7 errors in it. Can you find anything more? Who's first? What's the first horrible error? SQL injection, yes, of course, SQL injection. Next. Yeah, that's more of a performance thing. Yeah, I should dispose of them. That's right. That's actually a new one, number 8. Thank you. Because that could be used as a denial of service to exhaust resources. It's a new one. The cookie is open text, the most ridiculous thing. I mean, anyone can just put any username in there. Sorry? You always redirect. I always also set the cookie. I forgot the else. So it doesn't matter what you say. If you put in the wrong username and password, you will have a modal error that will be added, but it will be ignored. Okay, this is bad. So the way to handle authentication is to use a pre-made solution. This is a quote from the OWASP Top 10, where it says, ideally, use a pre-made, well-trusted system to handle authentication, identity, and session management. Transfer this risk whenever possible by buying and utilizing a hardened and well-tested system. So how does ASP.NET Core stand up to this? They have ASP.NET Core, ASP.NET Identity Core. If we have a beer in the party tonight, we can discuss some nuances of ASP.NET Identity, where I don't like the API surface and design, etc. But in general, it's secure. It's a good choice to use. Or even better, add external authentication. Offload it to someone else, because you have all the components needed included in ASP.NET Core. We can have a cookie handler to manage our session, and then we use OpenID Connect to establish the session. Let's move on with number 8, software and data integrity failures. This was actually quite hard to find one of the examples, because all my old examples I had have been fixed. So ASP.NET Core, the typical examples that you usually have are XML, external entities, XML DTD, the billion laugh attacks, where you could send special XML that self-expand recursively. Things like that, they are blocked by .NET by default now. That's good. One example that I had that worked fairly recently is and still is worth mentioning, is deserialization of arbitrary classes. So if I receive a piece of data that is serialized and I deserialize it, I need to know what type to deserialize it into, right? One way to do that is to allow a marker in the serialized data to just tell what type it should be used. And you're shaking your hand, why?
Last year was the year I saw someone injecting some very complex thing in there and it created in this little class that a lot of generation.
So, someone injected something, yeah. So one of the things you can find in .NET is the temp file collection class. It's serializable. So if I have a deserializer somewhere that would happily deserialize any type I tell it to deserialize, I could send them a serialized temp file collection. I mean, why is it serializable in the first place? Can anyone explain that to me? It is. It contains a hash table of files that is in the collection. And then it contains a finalizer that cleans up and ensures cleanup. Which means that if I can send you a serialized version of this, I can tell it to I can essentially send a list of files that should be removed from your system. So in the Newtons of JSON version of this slide, I said that this is secure by default, but don't ever change this setting because then you're vulnerable. I checked system text JSON, what do? Type name handling.all, a global setting, not supported by design, period. They didn't just close the door, they removed the door entirely, which is good. Then we have security logging and alerting failures as number 9. This category includes also a variety of topics. It includes both injections. I mean, if you can force data to be written to the logs unescaped, you can make the logs unreadable. Structured logging helps a lot that we have in ASP.NET Core. It also includes where logs are stored on a server, so if the server is compromised, the attacker can remove the logs. I think one thing that has helped a lot here is OpenTelemetry and the move to OpenTelemetry. I see that this is really happening, has been happening over the last few years and is happening. Everyone is moving to OpenTelemetry, where you have a separate external monitoring tool and aggregator, which means that things are just shipped out. And ASP.NET Core has excellent support for that. So what they did is that ASP.NET Core had excellent support for, or built-in support for counters and measuring duration for activities. It's called activities in .NET. And we had the structured logging. What they did was just add an OpenTelemetry adapter on top of what already existed to export it to OpenTel compatible viewers. There is, however, another category of logging that isn't covered, audit logging. So OpenTelemetry is great, but it is a tool for monitoring the health of a system. It is not an audit logging tool. For example, OpenTelemetry often does sampling, and it saves things for just a few weeks. The idea is that OpenTelemetry, that tooling is made to make it possible for you to monitor the health of your system and to figure out why the system is down or why it's slow, what is your performance penalties, what kind of error messages or errors are your users running into. And it's an excellent tool for that. But if you, half a year later, does a forensic because you had a breach and want to know exactly what users logged on that Wednesday in August, OpenTelemetry was never designed for that. So if you have requirements for audit logging, you have to build it yourself. Another part of security logging failures is also exposing incorrect data. Here they can help. Microsoft Extensions Compliance Redaction is a fairly new library that allows you to classify data as personal information, etc., and they can have some clever redaction mechanism in there. One example is that you can decide based on what type of data it is, if it should be removed entirely from the log, or if you should store a hash of it. Why a hash? Well, because if you don't want to store personal data, username, social security number, whatever, but you may want to be able to correlate across logs. If you store the hash of the user identifier, then you can correlate if it was the same user across many different logs, but you still can't get to what it was. And that is a good idea to do in the technical logs with OpenTelemetry. However, in the audit logs, should you anonymize the user identity in the audit logs? No, the purpose of the audit logs is to keep them. So you need both of them. Final category, mishandling of exceptional conditions. Back in the days, ASP.NET had custom errors that were very chatty and exposed a lot of internal information. The developer exception page in ASP.NET Core is still detailed. It's even more detailed and provides a lot of things that are helpful when troubleshooting. But by default, it's only enabled if you run on the development environment. When you run it on production, it's disabled. And this is the default error page from a fresh project I created, that as it would be displayed for production. Just there was an error, there is a request ID, so if the user screenshots this or gets the request ID, you have something to use in your OpenTelemetry-based application monitoring to search for. But there's more to it. It's also about flow control. This is a naive order processing method. And this reminds me of my days when I was working C++, and one of the problems with C++ is that you need to free memory always. So it was really important if writing code that involved exceptions in C++, it was really important to make sure that if an exception could ever be thrown anywhere, you still would free the memory at least. And remember that. And it's kind of the same here. If we process an order, what would happen if we do it in this order and have an exception? Any one of these methods could throw an exception, right? If the first one fails, charge credit card, customer didn't have money, problem solved. We didn't do anything. What if we charge the credit card, but the license key creation fails? Profit. That is very creative. I would said public relations problem. I actually had a system once where we had failed. We had removed Google Analytics from the page, and we had forgotten to remove an event call on the payment page. So we did this. We took the money, we reserved the money, and then the order didn't complete because there was a failure to call Google Analytics, and the JavaScript aborted. It was extremely embarrassing. What if we create the license key but don't send it? Well, it depends on what it costs. This could be a license key that we create, and also once we create it, we have to pay a supplier. Well, we got the money at least, but still a bad idea. No. One way to do it is to think in terms of transactions. And once again, way back we had distributed transaction coordination, we had transactions, we could wrap everything in a distributed transaction and things worked. With a distributed environment today, that's no longer possible. But we can still steal some of the ideas from that. We can have a prepare phase where we reserve the money from the credit card. Just check that they have the money. We can create the license key and store it somewhere to make sure we have a license key. And once we've done these are operations that can easily be rolled back if needed. Then we have a commit phase where we mark an order as committed. Single instruction, if this goes through and the order is marked as committed, then we have decided that the order will be completed. Then we can try send license key and try confirm credit card, but We can also have a job in the background that monitors, retries. If one of these completion steps fails, we can retry it later. We can have monitoring that alarms that saying, hey, now the credit card confirmation or license sendings doesn't work, and catch them up later. This is not something that ASP.NET Core helps with, but it's an important part also of mishandling of exceptional conditions, that you think of what would happen to your flow or control when you do multiple things. So, looking back at the list, what is our verdict? Broken access control, does ASP.NET Core help? I would say yes. Security misconfiguration? I would say yes, it's fairly secure by default. Supply chain, could be better. And the experience from Martin showed that, yeah, there are still things that I wouldn't blame the NuGet team. They do a great job, but it's extremely hard to protect all the way. We need to be cautious ourselves. Cryptographic failures, yeah, the default helper methods, they are excellent. And I really love that they have this data protection abstraction that is easy to use and you don't have to learn. And also, if you fail the data protection configuration, it will not make your application insecure. It will make your application stop working maybe, but you will not lose the encrypted data or not give away the encrypted data. Injection, yeah, great tooling by default, both using link as a protection against the SQL injection. The default escaping is great. Insecure design is not a technical thing at all. Authentication failures, yeah, we have great authentication tools built in. Integrity or data failures, yeah, this is where I had it hard to even find examples because it's so good. Security logging and alerting failures, yeah, I would say that this is a question mark, and I think the audit logging is the large thing missing here that I find missing. And my final verdict, exceptional conditions, is that, yeah, it doesn't leak information, but there is no build. You are on your own to design your business logic so that it recovers gracefully or errors gracefully in case of exceptions. So I guess I'm out of time. No, nearly. I have time for one or two questions. We're in Scandinavia. I'm Scandinavian myself. I know what it is. So I'll be around for the rest of the day and Oslo tomorrow, so just grab me if you want to discuss. And otherwise, thanks a lot for coming and thanks for being here.